Have you ever looked at your CPU specifications and wondered, how can an 8-core processor suddenly become a 16-thread processor? Did someone secretly hide 8 extra cores inside the chip? For years, companies have advertised technologies like Intel hyperthreading and AMD simultaneous multithreading, or SMT, promising more performance without adding more physical cores. But here's the question that really matters. Is hyperthreading actually useful, or is it just clever marketing? Some people swear it makes their PC noticeably faster. Others disable it immediately, claiming it hurts gaming performance. So, who's actually right? Today, our Snowman is going to shrink down to the microscopic world inside a CPU to find out exactly what hyperthreading is, how it works, when it helps, when it doesn't, and whether you should actually care about it in 2026. By the end of this video, you'll know why one physical CPU core can sometimes behave like two, why AMD calls it SMT instead of hyperthreading, and why the answer isn't as simple as more threads equals more speed. And trust me, one of the biggest myths about CPUs is about to melt faster than our snowman in the desert. Before we can understand hyperthreading, we need to answer one simple question. What exactly is a CPU core? Think of a CPU as the brain of your computer. Every click, every game, every video you watch, and every program you open eventually becomes a series of tiny instructions that the CPU must process. Inside that CPU are smaller processing units called cores. You can think of each core as an incredibly fast worker that follows instructions one step at a time. But here's something many people don't realize. A modern CPU core isn't doing just one thing. It's constantly fetching new instructions, decoding what they mean, performing calculations, moving data, predicting what might happen next, and writing the results back to memory, all billions of times every second. Imagine a professional chef in a busy kitchen. The chef isn't just cooking. They're grabbing ingredients, waiting for water to boil, checking the oven, chopping vegetables, and plating meals. Some tasks keep the chef busy, but others force them to wait. Surprisingly, CPU cores have the exact same problem. Even though today's processors are incredibly fast, they often spend tiny fractions of time waiting for data to arrive from memory. Those delays may last only nanoseconds, but when they happen millions of times every second, valuable computing power is left sitting idle. And that's exactly the problem engineers wanted to solve. Instead of building an entirely new physical core, which costs more silicon, more power, and more money, they asked a smarter question. What if one core could stay busy by working on another task whenever the first one has to wait? That single idea became one of the most important innovations in modern CPU design. Now comes the big question. If your processor has only 8 physical cores, how does Windows suddenly report 16 threads? Did the CPU magically create 8 more cores? The short answer is no. Hyperthreading doesn't create new physical cores. Instead, it allows one physical core to manage 2 independent streams of instructions, known as threads. Think of a CPU core as a highly skilled office worker sitting at a desk. Normally, that worker handles one stack of paperwork at a time, but every now and then they have to stop and wait, maybe for a file to arrive, a document to load, or someone else to finish their part of the job. During that waiting time, the worker isn't being productive. Hyperthreading changes that. Instead of leaving the worker idle, the desk now has 2 stacks of paperwork. Whenever one task has to wait, the worker immediately switches to the other one. The worker is still the same person. The desk is still the same desk, but much less time is wasted. That's exactly how hyperthreading works inside a CPU. The processor duplicates some of the architectural state, such as registers and control information, so the operating system sees 2 logical processors. However, the expensive execution hardware, like arithmetic units, caches, and execution pipelines, is still shared between them. This is why Windows might display 16 threads on an 8-core CPU, even though there are still only 8 physical cores doing the actual work. In other words, hyperthreading improves efficiency, not raw hardware. It's about keeping valuable CPU resources busy instead of letting them sit idle. And that's why it doesn't magically double your performance. So if 2 threads are sharing the same physical core, how does the CPU decide which one gets to run? To answer that, we need to take a quick look inside a modern processor. Every CPU core contains several important components. There are instruction decoders that translate machine code, execution units that perform calculations, registers that temporarily store data, cache memory for ultra-fast access, and a branch predictor that tries to guess what instruction comes next. When only one thread is running, some of these resources aren't always fully utilized. For example, while one instruction waits for data from memory, an execution unit might be sitting there doing absolutely nothing. That's wasted performance. Hyperthreading gives the CPU another stream of instructions to choose from. If the first thread is stalled, the processor can often schedule instructions from the second thread instead. Notice the word often. It doesn't happen all the time. If both threads need the exact same execution units at the same moment, they have to compete for those resources. Just like two cars trying to merge into a single lane, one of them has to wait. This is why hyperthreading is not the same as adding another physical core. Two real cores have their own dedicated hardware. Two hyperthreaded threads share most of the same hardware. That's also why performance gains vary. In some workloads, hyperthreading might improve performance by just a few %. In others, it can provide gains of 20, 30, or even more. It all depends on how efficiently the workload uses the shared resources. The secret isn't creating more power, it's making better use of the power that's already there. Now that we know how hyperthreading works, the real question is, does it actually make your PC faster? The answer is yes, but not always. In productivity workloads like video editing, 3D rendering, software development, virtual machines, compression, and multitasking, hyperthreading can provide a noticeable performance boost. That's because these workloads usually have plenty of independent tasks that can keep both logical threads busy. For gamers, however, the story is a little different. Most modern games benefit from hyperthreading, especially open-world titles, simulation games, and games that perform lots of background calculations. But the improvement is usually modest, often around 5 to 15%, and in some titles, the difference is almost impossible to notice. In rare cases, especially with older games or poorly optimized software, hyperthreading can even reduce performance slightly because both threads are competing for the same CPU resources. Fortunately, modern game engines and operating systems are much better at scheduling threads than they were years ago. What about AMD? AMD uses a technology called Simultaneous Multithreading, or SMT. While the internal implementation is different, the overall goal is exactly the same. Keep CPU cores busy by allowing two instruction streams to share a single physical core. So, whether you're using an Intel processor with hyperthreading or an AMD processor with SMT, the idea remains the same: improving efficiency rather than creating extra hardware. You may have also heard people recommending that you disable hyperthreading. Years ago, certain security vulnerabilities, such as Spectre and related side-channel attacks, led some enterprise servers to disable hyperthreading in highly sensitive environments. However, for the average home user, gamer, or content creator, modern operating systems and CPU microcode updates have greatly reduced those risks. So, should you disable it? For almost everyone, no. Unless you're troubleshooting a specific issue, chasing benchmark records, or following a software developer's recommendation, leaving hyperthreading enabled is usually the best choice. So, is hyperthreading actually useful? Absolutely. But not because it magically doubles your CPU's power. Instead, it makes your processor smarter. It reduces wasted time, improves efficiency, and helps your CPU stay productive whenever possible. It's not fake performance. It's not free performance. It's simply better utilization of the hardware you already paid for. And that's why, after more than 2 decades, hyperthreading and AMD's SMT remain an important part of modern processor design. I'm Snowman, and if this video helped you finally understand one of the most misunderstood CPU technologies, consider subscribing. We've got plenty more deep dives into processors, GPUs, and the future of computing coming your way. Thanks for watching, and I'll see you in the next one.